Hi. Well, we're going to continue on and wrap up the last title here for communication and navigation. That's Autopilot Part 2. All right, I don't have much to say about a lot of these slides. Basically, it's just showing how the motor is hooked by way of a cable and a bridle clamp to one of the main control cables. So it's in effect the same control cable that is hooked to the cockpit controls for rudder, ailerons, etc. But there's an additional servo attached. This one here is actually pneumatically operated from suction from the controller. This one here is a DC motor that's operating the mechanism. They point out it is reversible, so basically you can adjust a little bit this way and then a little bit the other way. Reduction gears, nothing too much there. DC motor, suction, pneumatic. DC motor. They're basically showing the operation of clutches so that the motor will in effect stop and start more instantaneously, so you can get those slight little adjustments on the control cable. See how the cable is wrapped around the device known as a capstan. Electrohydraulic. Basically, there's hydraulic elements, which basically is shown quickly. It looks like the black in the illustrations. And depending on the forces on either side, there's a way to move the system by use of hydraulic fluids, in effect. The control surface actuator, that's probably more the piston that actually moves the system. What does the text say here? Or the caption? They're mostly talking about a servo valve when you're powering your autopilot system with hydraulics. Linear variable differential transformers. The elevator control on a large transport category aircraft. You can see the elevator here, which is located on the horizontal stabilizer. And it looks like there's 3 actuators or hydraulic servos that are operating the elevator. I don't think anything else is basically showing us. Here's that PCA again. Power control actuators. Cessna, there are models that have an autopilot. It's a single axis, so not all 3. Just so you're aware, some of the smaller aircraft you work on may have parts of the system. This one looks like it operates on the ailerons, but not on the rudder or the elevator. Name the basic components of an autopilot system. Okay, I guess go right through either the block or the steps. You have the sensing elements, which you can name the various gyroscopic instruments in the altimeter. You have in effect a computer. They may call it the control. You have a control panel that's usually in the cockpit, and then you have the servos, or the actual actuators, and the actual actuators. There we go. That's probably all they need. Gyros, servos, a controller, and an amplifier. Again, didn't use the amplifier word. What component of an autopilot system applies torque to the control surfaces of an aircraft? What's the part that actually applies the torque? That's actually the function of the servo, so it's going to be the final answer, or option C in this case. The gyro is the sensor, and the controller is the control portion of the system. Servo. That's the part that actually applies the force to move the flight control surfaces. What's the main purpose of a servo in an autopilot system? Apply the torque necessary to actually move the control surface. Let's see, it doesn't look like any of that. So far B looks the closest, but A, correct for displacement of the aircraft about its axis. If you were hard pressed for any other answer, it's not totally wrong. B, but move the control surface as commanded. That's mostly what you couldn't say it more succinct. Or C, change mechanical energy to electrical energy. Well, it shows that you haven't really looked into the autopilot system. It shows a little confusion there. Sorry. So it is B, the simplest of the answers. What is the function of the servos in an autopilot system? I believe I put all the servo questions together here. So, apply torque to actually move the desired control surface. Actuate the flight controls. Did mention the control panel. It's on the flight deck. This particular control panel, as a flight director and an auto throttle, let's double check because these don't necessarily go together. All right, so basically the flight director is the button on the far left, and the auto throttle is the switch right next to it, so apparently it does. This control panel has other items like your navigation radio, you can kind of tell HDG heading. We don't deal with approach. IAS indicated airspeed. ALT altitude. Yaw damper. We mentioned auto throttle. Basically, it's this is probably closer to cruise control because this is what your automobile with cruise control would do. It would automatically accelerate or deaccelerate, and that means actually moving the throttle itself. The output servo moves the throttle linkage to set the level of engine power that the TMC calculates. The system includes sensors on the engines and monitors the important engine operating parameters. Flight director. We saw that was the far button on the left. One advancement in the flight instrumentation is the flight director. Basically, there's a bow, this yellow bow, acts as a steering bar. That is normally where they will suggest that you be. That represents the aircraft. So in this case, the flight director is telling the pilot to pitch the nose up. So if you were in level flight, you would be right here on the horizon. But it's saying pitch up. In this case, it would be like 10 degrees. And turn or bank to the right. All right. It does it the same way as the horizontal situation indicator, which I believe we have a slide on that also. So flight director, horizontal situation indicator, very similar. Control wheel steering. So instead of just moving the flight surfaces, wouldn't it be better if it actually moved the yoke? And so what do we have here? Control wheel steering is an operating mode for the autopilot in addition to the command operating mode. The command mode is the normal autopilot mode in which the pilot does not touch the controls because the autopilot is actually flying the airplane. But in control wheel steering, the autopilot maintains the pitch and roll attitude existing at the time of the engagement. When the pilot wants to change the attitude, light pressure is applied to the controls as in normal flight. And the force is in effect recognized, measured, and then is used as a signal for the autopilot computers. So in effect, the human pilot is flying the airplane, but the autopilot is actually moving the control surfaces. Because that's instinctive what the pilot would do. Make a slight adjustment. A force transducer. 3 electrical windings and the armature above them make up a special type of variable transformer. Be aware of its existence. And there's not going to be any questions on this. Stability augmentation system. Basically, there are some automatic things that happen to a plane in flight that basically flight engineers have worked around a little bit. And one of them is this little crab angle that the aircraft has a tendency to come in order to keep it on the center line of the aircraft. You have a crosswind or something, in effect, you're coming in at a crab angle. There is a stability augmentation system if there's an auto land capability and a special operating mode called runway alignment. In an autopilot, which signal nullifies the input signal to the ailerons? Quite a little question here. All right, so they're giving us 3 different signals: quartz signal, follow-up signal, or the displacement signal. And I know none of the slides that we looked at really went into that much detail about it. So you want to nullify the input signal. So basically the servo kind of move the aileron a little bit because you want it to get a little roll. But now that you got to the right correct on the spot on the roll, you want to basically let it up a little bit and try to hold that course. What is that second signal? Since it's a second signal, I'm going to say it's probably the follow-up signal, but they may have a special nomenclature that is attached to it. It is the follow-up signal. And it basically works up as an offsetting type signal. And when the two signals are equal in magnitude, the servo basically stops moving. If you care about the actual mechanics of that, but yeah. Okay, you start with an input signal. What would be the next one? It would probably be a follow-up signal. What will occur if an aircraft attitude is changed by its autopilot system in order to correct for an error, and the involved control surfaces are returned to streamline by the time the aircraft has reached its correct position? Kind of talking about that with a follow-up signal. Basically, they corrected for an error. They had to turn the rudder, but and then it goes back to normal. And so because of that, the way it's phrased, I'm going to say that is normal operation. The overshoot and undershoot and oscillations, that's not the correct answer for this one. I believe there may be a question where we deal with that a little bit more. Yeah, this one's just normal operation. There was an error, let's say a little turbulence knocked it down. So the flight level has changed, and you want to go back to the higher elevation. Basically, the elevator will pitch the nose up until you get to the desired elevation, and then the control surfaces will be returned to streamline. That's how the autopilot actually works, so normal operation. Which of the following provides manual maneuverability of the aircraft while the autopilot is engaged? Is that the one where we touched the yoke in order to make some slight adjustments? All right, so what are our options? A, directional gyro indicator. I don't really see how an indicator is going to give us manual maneuverability. C, a servo amplifier. Or C, a flight controller. Well, just because of the non-fit of the indicator or the servo, it's got to be the flight controller. And the flight controller happens to be the component in an autopilot system that allows the pilot to maneuver the aircraft manually when the autopilot is engaged. Similar to your cruise control, you can increase and decrease the velocity. On modern large aircraft, what electronic device typically monitors flight parameters and performs autopilot functions? Well, I'd start looking for the word gyro, but let's see. Oh, electronic device. All right, so let's see what our options are. A, the control or the display unit. C, a transponder. Or C, the flight management computer. Well, we know computer's an electronic device, and it certainly fits in with the flight management of monitoring flight parameters. So flight management computer. We mentioned briefly the yaw damper. It's a phenomenon more for pilots. It's a it's tied in. Yaw damper is tied in with this Dutch roll, yawing action, similar to when we were talking about you're coming in at a crab angle. Well, this is similar. A yaw damper is installed in many swept-wing airplane to counteract Dutch roll, and that it's an undesirable oscillation. Basically, a rate gyro senses the oscillations. Signals are sent to the servo, and there's some corrections, some maneuvers or some adjustments made to the rudder to cancel out the oscillations. You know, you can study this a little bit more, I guess. The illustration pretty much is showing what's happening. And how do you avoid that? Well, right here. As a matter of fact, I think it's probably the first question coming up here. Sure is. Dutch roll, a combination yawing and rolling oscillation that affects many swept-wing aircraft, is counteracted with A, a yaw damper system. Sounds good to me. B, an aileron damper system, or a flight director system. All right, Dutch roll, yaw damper. A. All right, I guess that's going to wrap up this series, and I'll join you again on the flip side. All right, thanks.